Hi guys, welcome to this set of videos, and what we're going to do here is we're in chapter 6, and now we're actually going to begin our discussion on radical functions, expressions and functions that contain radicals or square roots in their simplest form. And so what we're going to do here, again, to get our sort of discussion started, is to sort of get a couple of objectives or learning targets to sort of help us focus our attention on really the important stuff you want to pull out of this set of notes. So let's go over those first, and then we'll jump right into these radical expressions and functions. The first thing you're going to want to be able to learn as we go through these notes, what you should be able to do by the time we get to the end of this set of videos, is you need to be able to graph and analyze square root functions. And then the second thing we're going to look at is graphing square root inequalities. Guys, we have been graphing in every single chapter we have done so far this year in Algebra 2. It shouldn't surprise you one bit that we're going to start our discussion on radicals with graphing. It's what we do in Algebra 2. We do a lot of graphing. So here we go. Let's just jump right into this. I mentioned at the end of section 2 why we had spent so much time talking about functions leading up to radicals. In section 2, we had begun a discussion on inverse functions, and I just remind you of that right here. If you are given the function f of x equals x squared, which I've graphed right here, y equals x squared, it's a parabola, it's a quadratic function. You guys know what those look like. The inverse, which we showed you how to find back in section 2 of the squared function, the x squared function, or the quadratic function, is the radical function, the square root of x. So f of x, x squared, and f inverse of x, the square root of x, are inverse functions. And again, I can show you that pretty simply right over here. If you just recall for me real quick, the way that we determine whether functions are inverses or not is by doing the composite functions. So if I do f of f inverse, right, that composite function should come out to just be an x. Well, that means I need to start with the function f of x, which is x squared, and plug f inverse of x into that function, which means I'm going to wind up with the square roots of x squared. Well, you guys already know that square and square root cancel each other out, and I'm left with just an x. But that's not all. I would also need f inverse of f of x to also come out to be an x, where I plug f of x into f inverse. Well, that means that I'm going to plug x squared into the square root of x, which means I would have the square root of x squared. Once again, square root and square cancel each other out. I'm left with just an x, and by definition, because the composite functions come out to be the identity function, I know that f of x and f inverse of x are inverse functions. I guess I probably should have called this guy g of x. Obviously, they're inverse functions. I'm calling this one f of x and this f inverse of x. But you can see, right, I've just shown you how it works. These are definitely inverse functions. X squared and square root undo each other, right? They're reverse operations. Right? Now, a couple other things about the graphs of these guys. You guys learned back when we were dealing with the quadratic functions and solving quadratic functions, we every now and then would have to take the square root of a quantity in order to get our solutions. And what you guys had to remember to do was every time you took a square root, you needed to do plus or minus. But you should notice here that I do not have f inverse of x is equal to plus or minus the square root of x. It's missing. I didn't put plus or minus here. And I did that for a reason, and here's the reason why. So just a quick note for you. Right? This is a function. And in order to be a function, it must pass the vertical line test. In order to be a function, the square root of x must pass the vertical line test. Let me show you. Right over here, I've got the function y equals x squared. We know that parent function. We've been dealing with it quite a bit. I can draw a vertical line anywhere through that function, right? It only intersects the function at exactly one point, meaning it passes the vertical line test, and f of x equals x squared is a function. Well, in order for f inverse of x to be a function, I also need the square root of x to pass the vertical line test. So what I've done is I've graphed I've graphed y equals the positive plus square root of x. Please keep in mind, if I had done plus or minus the square root of x, that graph would actually look like this. It would have this little part right down here, the negative part running in that direction, right? That would be the negative square root of x. But if I graphed y equals plus or minus the square root of x, please notice, you can clearly see, I draw a vertical line through there and I fail the vertical line test. My vertical line would intersect y equals plus or minus the square root of x at two spots, meaning it's not a function. And that's not okay. I want it to be a function. So what we do is we ignore, for now, the negative part of the square root, and we only consider the positive square root of x. So when I graph y equals the square root of x, please, at this point in this chapter, you no longer need to remember to do plus or minus. Actually, I will let you know which one I want, right? If I show it to you as a positive square root of x, I only want the positive values. If I want the negative values, I'll tell you. And the way I'll tell you is I'll put a negative sign out front. In which case, I don't want the positive values of the square root of x. I want just the negative values of the square root of x. And if I want them both, again, in this chapter, I'll tell you I want them both by putting plus or minus in front. Of course, then you wouldn't be able to graph it because it wouldn't be a function. But I would tell you if I wanted plus or minus. So anyway, we graph y equals plus or minus x. I only graph the positive numbers, and I get a function that passes the vertical line test. Or actually, it is a function because it passes the vertical line test. Now, one quick note, you should recognize this from all the way back in chapter 2. What that means is y equals the square root of x is our parent function. That's right. Here in this section, when we deal with graphing, we are going to look at transformations of graphs. So, y equals the square root of x is your parent function. And in that parent function, a is equal to a plus 1, h is equal to 0, and k is also equal to 0. Remember, h is the horizontal shift, left or right, but you have to remember it's the opposite. K is the vertical shift, up or down. It works exactly the way you would think. A just simply tells you whether the graph is above or below the x-axis. Remember, it's a reflection across the x-axis. And A also tells you whether it's a vertical stretch or a vertical compression. And we'll talk about that a lot more when we actually get to graphing. So y equals the square root of x is your parent function. It starts at the origin and just curves off gently, headed to the left. Now, before we get into graphing, there's one other really important thing I got to talk to you about when it comes to these radical functions, and it's this idea right here. There are going to be values that we're going to need to exclude or eliminate or just leave out. So check this out. When graphing a square root function, you'll need to determine when the radicand would be negative and exclude those values from the domain. Let's talk about what this means for a second. First of all, what is the radicand? Oh, hold up. Sorry, that's my highlighter. I want my pen. So, your first note is this. The radicand is just what is under the radical. All right? It's just what's under the radical symbol. So for me, the radicand in this example problem is x plus 4 because that's what's underneath of the radical symbol. If I had a bunch of other stuff in here, if I had a 2 out front, so I had 2 times the square root of x plus 4, and then I had a minus 5 on the end, right? If I had given you, I don't know, let's say this guy, if I had given you 2 square roots of x plus 4 minus 5, right? The radicand is just what's under the radical. It's just the x plus 4. Just the x plus 4. I don't care about the 2. I don't care about the minus 5. It doesn't matter. It's just what's under the radical symbol. That's the radicand. Now, here's what I'm telling you, right? The radicand can't be negative. Well, you guys know why the radicand can't be negative. Let's review that here real quick. If the radicand, this x plus 4, comes out to be a negative number, what happens? Well, if this comes out to be a negative number, then you're taking the square root of a negative number, which we know is imaginary. Now, that's not bad, right? We've done plenty of problems where we've gotten imaginary the solutions. The issue is we're graphing, right? We're not asking you to find the solutions. I'm asking you to graph, and we don't graph imaginary numbers. So your second note is this. If the radicand is negative, then you will get imaginary numbers. Which is no big deal. Imaginary numbers are no problem, really doesn't matter. We've been dealing with imaginary numbers in previous chapters. We know what to do with them. They're perfectly fine solutions. We're okay with that. That's not the issue. The issue is we're trying to graph, and I can't graph imaginary numbers. And so that's why I do not want my radicand to be negative. Not because imaginary numbers are bad, they're perfectly fine. I just can't graph them. So we're gonna leave them out. If the radicand is negative, then you will get imaginary numbers, and we can't graph imaginary numbers. Well, not that we can't. We're not going to graph imaginary numbers. Let's put don't. So, I am not excluding values where the radicand is negative because I don't like imaginary numbers or I don't want imaginary solutions. That's not the reason. The reason is because I'm not going to graph imaginary numbers, so we're just going to ignore those guys. Now, another real quick note here is this, all right? Let me show you how this works by doing a number line. I think this will make a lot of sense for you guys out there. As you're watching this, let me draw you a number line. 0, 1, 2, 3, 4, 5, 6, 7, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Okay, now, here, please, again, read this definition, right? Read this very, very carefully and understand what I'm saying here. When graphing a square root function, you need to determine when the radicand is negative and exclude those values from the domain. Here's what I'm not saying. I am not saying that all negative numbers get left out. That is not what I'm saying. What I'm saying is you have to exclude values that make the radicand negative. Watch this. What if I were to pick the negative number? You know what? Let's go with minus 3. We're going to go with this negative number right here, minus 3. I plug a minus 3, I make that my domain value, and I plug that in. All right, so I'm going to plug a negative 3 in for x into my radicand. Minus 3 plus 4. Well, what is minus 3 plus 4? Minus 3 plus 4 is a 1. Can I take the square root of 1? Yeah, you betcha you can. The square root of 1 is 1. That is perfectly okay, and I used a negative number. Again, I am not saying that you need to eliminate or exclude negative numbers. What I'm saying is you need to exclude numbers that make the radicand negative. Let's do another one. What if I plugged in a negative 5? Well, if I plug a negative 5 in for x, minus 5 plus 4 is a negative 1. Well, when I take the square root of a negative 1, I get an imaginary number, and now I have an issue. Not because I don't like imaginary numbers are fine, but I'm not going to graph an imaginary number. So here's what I know. Negative 3 is okay. Negative 5 is not okay. It's giving me an imaginary number, and I'm going to want to exclude that value. So actually, you guys can probably pretty clearly see at this point, the way this is going to work is you are simply going to take your radicand, right? The values that I'm plugging in, right? Negative 4, I plug in a negative 4. Negative 4 plus 4 is 0, and the square root of 0 is 0. So what I found is everything from negative 4 in this direction are all values that I can plug in. Everybody less than negative 4 is going to give me an imaginary number, which I can't graph, and so I'm not going to use it. So negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, all the way to infinity. Those are all values in my domain, right? So my domain is going to be x is greater than or equal to a minus 4. Sorry, that is a terrible D. That's my oh, I did it again. That's going to be my domain, right? And so what I've done is I have excluded, I've left out the values that give me imaginary numbers because I'm not going to graph them. So starting at negative 5, negative 6, negative 7, negative 8, right? Anything less than negative 4 is excluded. I'm not going to keep it. Now, I don't need you guys to give me a number line every time. I'm just hoping the number line helps you picture what's going on here. You're not leaving out negative numbers. You're leaving out numbers that make the radicand negative. Just what's under the square roots, or just what's under the radical symbol. Now, another way of doing it, here's what I'm actually going to ask you to do. The simplest way to do that is this. Please notice that negative 4, right? I want everything greater than or equal to a negative 4. All you have to do is take your radicand and set it greater than or equal to 0. If you like the number line, please feel free to draw them, and I'll continue to draw the number line a couple more times just to help you guys see it. But again, you don't have to draw the number line every time. Actually, here's all you need to do. My radicand was x plus 4. I set that greater than or equal to 0 and solve for x. X is greater than or equal to a negative 4, which is exactly what I got for my domain by taking a look at a number line. I know that anything less than 4 is going to be excluded. I am only going to keep domain values that are greater than or equal to negative 4. So guys, please feel free to just do this. This is really all I need you to do. Again, just to help us sort of picture it as we do the first couple of problems, I will show you the number line because it makes for a great visual to see what's going on here. So really important things. X squared and square root of x are inverse functions. I'm only going to graph positive square root of x because I need it to pass the vertical line test. And when graphing